rains a lot this time of year. And we both go together if one falls down. I talk out loud like you're still around. No, no. And I miss you. I'm going back home to the West Coast. I wish you would have put yourself in my suitcase. I love you, standing all alone in a black coat. I miss you, I'm going back home to the West Coast. And if you shake her hard enough, she will appear. Tonight I think I'll be staying here. And you never did like this town. I talk out loud like you're still around. No, no. And I miss you. I'm going back home to the West Coast. I wish you would have put yourself in my suitcase. I love you, standing all alone in a black coat. I miss you. I'm going back home to the West Coast. Come on, everybody.
Please welcome David Copey, MongoDB Director of Information Strategy.
Thank you. Good morning, everybody, and welcome to MongoDB.local Houston. All right, that was good. Little delay. We have over 400 people registered for this event. Isn't that amazing? Welcome to Houston. It's getting a little chilly outside, so hopefully everybody brought a jacket. Just going to run through some quick housekeeping things and kick off the session. Make sure you take note of the code here. MongoDB World in New York next May is our flagship event. I'm sure many of you have been to it before. We're offering a very aggressive discount here, so you can sign up early for that event. Lots of customer presentations, sessions, meet the experts, flagship event. It's fantastic. Everyone's always loves that event. So we're doing this very, very good discount if you want to get signed up. We also will be doing a happy hour later today. Everybody loves a happy hour, 5:15 in the foundation room. Looking forward to joining everybody there. We also, these events are really for you, right? So this is all about helping you as our evangelists out in the real world, promoting and using MongoDB. So we need feedback from you on what worked, what didn't work, what you'd like to see more of, less of, etc. So you will be getting a survey. Please fill that out. It helps us tweak the event and do more of the things that you need to be more effective using MongoDB. And of course, no event would be complete without swag. So please make sure you pick up your swag later. Big thank you to our sponsor, DataVale. Give them a round of applause, please. They help us make events like this happen. They have a booth downstairs. I'm sure you saw it on the way in, along with our other booths. So mingle with them. We have some great sessions later. There's Ask the Experts. There's booths downstairs. You can discuss all of the latest, greatest capabilities of MongoDB and learn all the stuff that you came here to learn. So with that, I'd like to hand it over to our keynote speaker, Dr. Grigori Melnik. Let's hear it for Grigori.
On a mission. Yeah, that's right. I'm on a mission here, guys. Hello, Houston. Great. My mission is to actually show you today why MongoDB is the best data platform to power modern applications. That's a big feast. Well, let's make sure that we understand what we mean by modern applications. So first and foremost, modern application platform must support developer productivity, right? These days, hardware is cheap, software is cheap. The most costly resource that you have are your developers, so you want to make sure that developers can work with the data in an incredibly easy way. You also want to make sure that your infrastructure is agile and flexible enough to support you. You don't want to be fighting or working around your database. You want the database, the infrastructure, to work for you. You never know where you're going to deploy. Maybe today, but tomorrow you don't. You don't know what kind of scaling needs you may need in the future. So you want to make sure that the infrastructure is flexible enough to support that type of requirements. Now, if you think about us generating a lot of data, these days are pretty good. Everybody's good at generating data. We're not that good actually making sense of it, but we're good at generating tons of data, storing it all, right? And storage is so cheap that people today don't even store away data. We don't delete data, right? We store it in perpetuity. And as we do that, the data tends to have this quality of basically becoming more and more polymorphic. So you want to make sure that your database can support that type of new requirements and that type of data evolution. And then lastly, you want to make sure that your platform supports the impatient and demanding users like myself, who all want their data right here, right now, device, and doesn't matter where they are in the world. So if your platform, if your data platform doesn't support these four, then it's very likely the developers are going to go somewhere else. Now, MongoDB is the best database for modern applications because of these three key tenets that it's built on. The document model, first and foremost, at the heart of everything we do from day one. The powerful distributed systems, and the ability of MongoDB to run everywhere. Today, we're going to talk about how we're making it easy for you to work with data with the latest advancements to MongoDB and the underlying platform. Of course, we're going to talk about the new release and the core database improvements, MongoDB database itself. We're going to talk about how we're making it easier to operationalize the database. We're going to talk about the operational experience. And also, we're going to talk about what we're doing going beyond the core database and offering a new set of services that comprise the MongoDB data platform. First, let's talk about the core database. So it's built on two, as I said, core things, document model and the super powerful distributed systems. And if we're thinking about the document model, let's answer the question, why documents? Why documents? Why document model? Well, first of all, the document model, as many of you know, supports a more natural way of doing data modeling, okay? So say you are modeling an entity like a person, right, with a bunch of different attributes and everything. You do not want to decompose a person into rows and columns, right? And then furthermore, shard it and place it in like different places somewhere. Please don't. That's considered creepy, right? So instead, you want to keep it all together. Now, when you have the powerful data modeling way, you also want to make sure that you can query those documents effectively, right? You want to make sure that you have a robust and fully capable query language, and that's what we have as well, MongoDB query language with the underlying aggregation framework, which is super, super powerful. And then lastly, you also want to make sure that your schema can evolve with your requirements, right? So the dynamic schema is something that MongoDB is built on as well. Now, having said that, we're also supporting validation rules and JSON schema validation, so you can be as fluid or as strict with your database schema as you'd like. The advantages of MongoDB being built from the ground up as a distributed system is that you actually get high availability as a first-class citizen, not something that was an afterthought, not something that was bolted upon your monolith database later on, but from day one, you get a high availability. You also get scale out so that you can elastically react to the changes in your throughput and loads. You can also take advantage of workload isolation. So if you have different workloads, let's say an analytical query, a heavy one, going against the same data that the transactional users are relying on, you don't want that to bring your transactional store to its knees. So you don't want the analytical and transactional workloads to step on each other. And this is something that MongoDB supports as well. And then lastly, geo-placement, something that will allow you to put your data close to where your users are, and you will take care of the data, you'll take care of the network latency and also make sure that you can actually take care of some of the regulatory requirements with geo-placement, geolocation. So, in 4.2, the release that just GA'd, like literally last week, MongoDB 4.2 general availability was announced last Wednesday, so it's fresh, out of the oven. Definitely take advantage of it. But there are a few highlights that I'd like to talk about today. We're going to talk about distributed transactions. We're going to also cover the enhancements that we're making to the high availability story. Excuse me. We're going to talk about the improvements to the query language. We're going to talk about the on-demand materialized views and something what we call wildcard indices. So get ready for this tour. Transactions first. We have introduced transactions in 4.0. They worked on replica sets. Just quick, let's remind ourselves what they were and how they work. Transactions in 4.0 are familiar. That's very important. There's nothing special about how you do transactions in MongoDB. Basically, something that you are all used to, something that you all know, just works the same way. They're conversational, so you can do your updates, reads, everything within a transaction. It's perfectly fine. And they're also quite performant. So first of all, if you are not using the transactions, you're not going to see any kind of impact on your database performance. But if you do, the impact is minimal. Like we've done the benchmarking, and it shows in our test a lower than 3% performance impact if you take advantage of the transactions. And if you do want to see those benchmarks, we're actually publishing a paper in the peer-reviewed conference, VLDB, later this month, so I encourage you to check it out. Now, let's take a look at a sample of how you would actually build a transaction. So this is a replica set transaction syntax, something, again, most of you are familiar with. You start a transaction, you do something inside, right? A few operations, and then you commit or you roll back. Everything is pretty straightforward, really nothing super new here. Now, in 4.2, though, what we're doing is that we're actually now supporting transactions in sharded clusters. So we're calling this distributed transactions, and now basically they work regardless of your deployment model. And this is super powerful. So let's take a look at how you would do transactions in a sharded cluster. This is what it looked like in the replica set. This is what it looks like in a sharded cluster. That's right. It looks exactly the same. Did you guys notice? I can't read you. You're all so silent. I worry you might be dead inside. Are you there? OK. So it looks exactly the same. There's absolutely no semantic difference. There's no API difference. It looks exactly the same. It works. It's very clean. It just works like magic. Now, if you are curious to know what happens behind the scenes, I'll just briefly give you a high-level overview of what's happening. So say you have a client. I have a MongoS router, and I have two shards, shard 0 and shard 1. A client chooses to start a transaction and issue an update command. Okay, the update happens to land on shard 1. That becomes the transaction coordinator. The client issues another command inside the transaction, another update. That goes to shard 0. Then it issues the commit, all right? The coordinator now says, great, get ready. All the shards do their stuff and then report back, yes, we're ready. And the coordinator says, go ahead, commit, and then reports back to the client, we're done. Just that easy, and as I said, it just works. Cleanly, beautifully, in a very performant way. It only costed us about $50 million to build this, so gosh, tough crowd, guys. Anyway, now, because now we have transactions in MongoDB, that doesn't give you a license to turn off your brains and to not think about the good and proven practices when it comes to data modeling. You shouldn't be using the data modeling the way you've done in the legacy world, working with tabular and relational databases. You need to apply the best practices and patterns of doing that in the document world. So let's take a look at this example. Let's say I have an order table, and then I have the line item table, and that was the foreign key linking it to the order table. I can do the same thing with two collections in MongoDB, pretty straightforward. And then if I need to update this data, I can actually go ahead and write this transaction, okay? And it will work. It will absolutely work. But this is precisely what you're not supposed to do, okay? Why? Well, if you think about it for a moment, line items are not distinct business objects. Line items do not live outside of the bounded context of the order. So in MongoDB, we have a way better way of dealing with this type of reference data, right? So instead, what you should do, you should embed it inside your document, right? Now, if I was to model orders versus inventory, well, maybe those warrant to be in separate collections. But in this case, this is absolutely something that should be inside your order collection. So, to recap, transactions in 4.2 are now distributed. They work in sharded clusters. The other thing that we did, we actually lifted the limitation of the transactions being 16 meg only. So now you can have them arbitrarily large. And you can also use transactions to change the shard key value. That's pretty powerful, right? Because at the back end, what's going to happen, actually, transaction will spin up to make sure that this is done atomically. And because now we can leverage the ability to change the shard keys, we can route the documents to appropriate locales, right, in Atlas global clusters. And you can actually, just by making this simple change, move the document from, I don't know, Sydney, Australia to West Coast or Houston. Also, I wanted to remind you here, transactions support the conversational syntax. They're fully ASCII compliant. Everything you expect transactions to be, you have. You can read your own writes, and, oh, that was too fast. And then they're identical to the replica fast transactions. If you want to learn more about the use cases for transactions, how to use them, if you want to learn more about the anti-patterns as well, we have a talk coming up later today by Ali that I invite you to attend. So that was transactions. Next, in 4.2, we've made some enhancements to the high availability story, especially the developer angle of that. So in 4.2, by default, every driver will retry reads and writes if they fail due to some kind of a transient failure, greatly simplifying your burden of writing the plumbing code that would have to handle that if you were to do it on your own, making you much more productive. and making your applications highly available. The next thing that we've done, we've introduced enhancements to the query language with the more expressive updates, filling the gap that we had before where you couldn't reference the data, you couldn't reference the fields within the document that you are updating. So if you wanted to do something like set A to be the value of B and C, and those are all the values of the same document, in the past, you would actually have to do it in your application logic. Now, you can actually do it right inside the database, which greatly simplifies the code that you have to write. Oh, and by the way, MongoDB 4.2 also supports a bunch of new aggregation operators, regex and rounding, a whole bunch of other functions. And then if you deal with the time, the $now is my favorite thing. So, next up. Oh, wait, that was too fast. Next up, on-demand materialized views, where previously, if you were going to pre-calculate some big aggregation and you wanted to have it on hand, you would actually have to replace it all the time with new data, right? Nowadays, we introduced the new operator $merge that actually allows you to update that view, put in less load on the database, so you can actually do it more frequently, keeping your views fresher. And then the last thing, the last highlight that I want to call out is the introduction of wildcard indexes. Indices has always been, pretty powerful in MongoDB, but when you're handling polymorphic documents, and rather than trying and second guessing the access patterns and trying to think about all the different ways how people may be using or querying your data, in some cases, it makes sense to allow the wildcard index, okay? And this is something that immediately comes up when you're thinking about modeling a product catalog that you need to search. And you don't know what attributes people may want to search on, or maybe you know today, but you don't know what kind of products would be added to the catalog in the future, and what kind of new attributes you may need to search by. So specifying wildcard index and letting MongoDB take care of that automatically is something that simplifies your job greatly. So in 4.2, there's a lot more. I only talked about the 5 highlights. Look on this slide, there's a lot more, and actually this slide doesn't cover everything. You definitely should check out the release notes. So why not take 4.2 for a spin and provision it in Atlas cluster? You can do it in a matter of a minute, and we do have a pretty generous free tier that will allow you to run it for a very long time without paying if you want to try it, right? The other thing, of course, you can download if you're on-prem. If you're running on-prem, you can download from the download center or from any of your favorite package managers. MongoDB database is the best database for modern applications. We truly believe that for any use case and any platform. But that story doesn't end. When you have a modern database, when you build in modern applications, of course you expect modern operational experience. And what do people expect? What do people want when we're talking about operationalizing database? What people care about, first of all, of course, is availability. Things break, and you want to make sure that they happen in such way that users do not notice. The data is available to them at all times. Even when you're doing some upgrades or whatever, you want to make sure that there's some kind of a roll-in way of doing that. Basically, your users should not notice any kind of breakages, right? You want to make sure that you have robust monitoring and alerting capabilities. So if things do happen, you have ways of troubleshooting it, and perhaps even preemptively setting up some actions that will help you to react to this in a better way. If something does go haywire, backup is key. And also, when people are working with the database, they want to do it in a self-service way. You do not want people to file JIRA tickets because they need to make some changes to the database, do you? I don't. And all of this needs to be topped by the very nice set of management APIs that allow you to have a single pane of glass into your deployment. There are 2 ways how we address operational concerns in MongoDB. If you're on-prem, it's MongoDB Ops Manager. And if you're running in the cloud, that's MongoDB Atlas. MongoDB Ops Manager is, in fact, the best way to run and manage your MongoDB deployment on-prem. It has a lot of very powerful capabilities, automation, and so on. But probably the most important one is the backup. And our backup is smart. It supports point-in-time restores, so that instead of getting some random snapshots, you can actually get based on the time. It also supports queryable snapshots. That's also big. Think if your backups are huge, I don't know, terabytes of data, petabytes, and you don't want to necessarily go and restore the entire set if you only need to get some value or just the subset. So you can actually issue a query and only restore that snapshot that results from the query. Now, previously, we actually, while backup was pretty powerful, we had some challenges, and we recognized them. The challenges were associated with just the number of moving pieces that you had in place in order to set it up, configure, make sure it works, and so on. That, of course, created the cost not only in humans, but also in terms of additional nodes and stuff like that, which was expensive. What we did recently, we have undergone a major architectural refactoring that streamlines the underlying architecture of backup and getting rid of heads. We're not relying on heads anymore. Instead, we're using wire target snapshots, making it much, much, much simpler and more robust. So Ops Manager Backup is available now. There's a talk that will help you understand it better, and I highly encourage you to take advantage of it. Now, when you are on-prem, right, the trend today seems to be that your developers still want to have public cloud-like experience, right? So everybody's talking about the private cloud and how do you get the same kind of experience, the same kind of tooling when you're on-prem. And the clear winner today is Kubernetes, right? How many people are using Kubernetes today? Can't see, it seems to be few. So what we did, in order to make your journey in the private cloud and the use of Kubernetes easier, we actually released a Kubernetes operator for MongoDB that supports management of complex topologies, deployment topologies, as well as VM scaling, different types of scale out, self-healing if something goes wrong, and comes with the full security out of the box. It's also available in any distro that you care about, open source, and then in OpenShift as well. If you want to learn more about the Kubernetes operator, please attend this talk later today. So that was the on-prem world. Now let's talk about the public cloud. MongoDB Atlas is our fully managed service, database as a service offering. Okay? In fact, it is the best way to run MongoDB in public cloud. It runs in all three cloud providers, Azure, AWS, Google, and is available in 60+ regions around the world. Okay? And this is important because basically this is like a provider-neutral offering. Now, while Atlas itself is great, lots of people want to integrate their operations in a single pane of glass so that they can manage it across with all other systems and applications. So we're building today integrations with Terraform and, again, Kubernetes through the Open Service Broker API, something that you can expect coming soon. Let's talk about scaling and auto-scaling. Atlas has two ways of doing auto-scaling. In the past, we were supporting disk size scaling, so we would add more disk space. Now we're also supporting VM scaling. And if your loads demand more, it would go size up your VMs. And if you're not using all the capacity that you provisioned, we would actually scale it down so that you are not paying for something you're not using. Very powerful, available today as a beta. Please test it out and do give us some feedback on this. Now, the last thing that I'm going to talk from the operations standpoint is the topic of security. Security is paramount clearly to any databases, not a database, any service, any public hosted service, right? And Atlas has some best-in-class security, including, of course, things like encryption at rest and making sure that all the data is encrypted when it's put on the wire, and we follow all the best practices when it comes to security. I'm also excited to share with you that we have achieved a lot of certification standards, things like SOC 2 Type 2 and HIPAA. And when we say that we accomplished this, we actually sign BAs to make sure that you're guaranteed you're safe on that front. We also have accomplished or reached the highest security certification, probably the strictest in the industry, ISO 27001 recently, which is very exciting. And we're right now working on the PCI compliance. Now, compliance is good, certifications are great for business, but no matter how many different certifications you might have accomplished, there's still certain kind of data that will always be a little uneasy putting into a public database as a service. This is what I'm talking about, right? Think about this document. The part of it where I'm listing the social security number is something that makes me and probably most of you developers, and of course your CISO, very uneasy, right? However, if instead of doing this, we put something like this in the database, that's not scary at all, is it? No, it's all encrypted. Now, here's what we did recently, and again, I'm very, very excited about this new capability of MongoDB. We introduced the new feature called field-level encryption, okay? Let's talk about what it is. First of all, it is entirely on the client side. It is baked into your driver. The database never sees clear text. Clear text actually never even gets on the wire. It's all happening in your client, okay? Also, the way we build it is that it is not impacting the MongoDB APIs, so you don't have to rewrite your application now because you want to take advantage of the field-level encryption. All of this will happen at the level when you're configuring your connection string. That's it. The rest of your code stays the same, so no impact on your apps and your developers. And then lastly, the most powerful thing about the field-level encryption is that you have several options of how you can choose your encryption key. You can pick an encryption key for the entire collection. You can do it per specific field if you like, or, which is really, really powerful, just think about it, you can pick it based on the user ID. Now, think about the use case where you need to delete a user, remove a user from your systems. It's not only removing it from the database, but then expunging all the data from all the numerous backups that you've got. Are you going to go and try to hunt for all of that? How? Right? It's like unpractical. There's no way to do that in an efficient way. With the FLE, with the field-level encryption, all you need to do is to just drop that key. You drop that key, the data is gone forever. There's no way to get it back. It's so powerful that this mechanism is equivalent to deleting the user and is recognized by the GDPR gurus as a way of ensuring the right to be forgotten. So if you care about the GDPR, which most of you should, this is something that will make your life a lot easier. It's available as a guided beta today, so I'm inviting you to sign up and try it out and give us some feedback. This will make us the most secure way to store data in the cloud. If you want to learn more, of course we have a talk today, right? To give you a deep dive into FLE. Please check it out later. All right, next, let's talk about things beyond the database layer. We're making data easy for developers, so of course we care about other things. So what you'll see is that we're expanding our data platform and support a lot of new things. We're supporting things like full text search and analytics and everything as far as real-time is concerned, and event-driven architectures, as well as mobile and data lake. And we're actually going to talk about all of this today. Let's start with the text search. Full text search is probably the requirement of any app today, right? Any application needs it, And the reality is that, how people who are using MongoDB accomplishing it today, probably doing something like this, right? So you have your database, you have your data in MongoDB, and then you have to siphon it somehow into this third-party application, maybe Elasticsearch or something like that, right? And then you have to figure out how you keep the data in sync. Of course, you have to manage and maintain the Elasticsearch deployment and all of it, just so that you can do full-text search. And of course, we know that both of those actually run on Lucene. So we thought we could do it better. We thought that we can make it much, much, much easier for you. We thought, why not to give the power of Lucene directly to MongoDB? Wouldn't that be phenomenal? Yeah, okay, yeah, warming up. I don't know, the coffee is working or whatever you guys are drinking or not drinking. So, well, even better, what if we bake it natively into MongoDB and make sure that then you get the support of the MongoDB query language and everything else? Or we thought that we can even take it further. We said, hey, why not to bake it inside Atlas so that you have the Atlas UI to configure your full-text search, and then you do not have to deal with the updates, maintenance, and anything from Lucene, while still getting the full power of Lucene for the full-text search. Now, if you truly want to appreciate the power of the full-text search, you guys need to see a demo. And I'm very excited to welcome Karen on stage to give you a demo of full-text search. Come on up, Karen.
Thank you, Grigori. Using MongoDB's new full-text search indexes, you can now easily integrate sophisticated search capabilities into your application. Let me demonstrate by implementing a simple full-text search on some sample data that Atlas provides. Here, in my Collections tab in my Atlas UI, you see my movies collection in my sample Mflix database. This collection has over 23,000 movie documents, each with different fields of varied data types, such as title, plot, and cast. Well, I want to build a search engine that's going to look for movies based on a topic. So to do that, I'll use full text search to look for specific words and phrases in this full plot field. The first thing I'll need to do is create a full text search index. We've made creating an FTS index as easy as possible. By default, we dynamically map every field in your collection. Mapping is simply how we define how the fields in our documents are indexed and stored. If a field's value looks like a string, then we treat it as a full text field. And mapping dynamically suits MongoDB's flexible data model perfectly, because over time, you'll add new data to your collection and your schema may evolve. We can accommodate those changes in your schema and add that new data to your index as well. And if you needed to map explicitly, if you only wanted to index on certain fields, or if you need to change your analyzer to Spanish, you could configure that here as well. Right now, though, I'm just going to accept the default settings and click Create. Now, to show you an aggregation that makes use of this index, let's switch over to Compass, our graphical user interface for MongoDB developers. Here inside of Compass's aggregation pipeline builder, you see the first stage uses the search beta operator to query for the terms werewolves and vampires in our full plot field. Next, we use $project to get back just the fields we want to use. This, in conjunction with the meta projection operator, we've built out an entire query to return movie documents along with their associated scores and highlights. This score signifies how well this movie document's full plot field matched the search terms werewolves and vampires above. And as you can see here in the right preview panel, the search beta operator returns these documents to us with the score in descending order, thereby giving us the best matched documents first. Export pipeline to language will bring us this aggregation pipeline in code. And it is this small snippet of code that powers our movie search engine. So let's see what this looks like in the live application. Here we'll look for those movies about werewolves and vampires. And as you can see here, as indicated by the scores below, we have very quickly searched all 23,000 movie documents to to return the best matched movies first. And you can also see here in the plot field the highlights that were surfaced by the meta operator. You'll see that werewolves is highlighted, as well as vampires. But what about and? Well, we've applied the standard Lucene English Analyzer to remove such common stop words, such as and or the, in order to improve the accuracy of our search. Now, this is a very basic use of your full text search index, but that same index enables so many more powerful search features. In this more advanced version, for instance, I've enabled type ahead to help our users find what they're looking for faster. Star Wars: The Empire Strikes Back, for instance. Or if I wanted to, I could still look for movies based on a topic. And as you see, I have a typo here in it, but it doesn't matter. I still get back my superhero movies, and that's fuzzy matching in action. Of course, all of these features I've just shown you can be combined with many others in different ways to help you build out even more fine-grained searches for your application. At MongoDB, we are passionate about making it easy to work with data. So we've made full text search something you could just turn on and query. Gone are the days where you need to sync your data across third-party systems and servers. So with that, we invite you to give it a try. Go to Atlas, click the button, and create a full text search index for your database. We can't wait to see what you create. And with that, thank you, Houston. You've been a tremendous audience. Mwah!
Thank you, Karen. So there's your Atlas full text search, fully integrated in Atlas UI, extremely easy to set up, and gives you the full power of Lucene. Great. Now let's talk about something else. Let's talk about the data visualizations. How many of you had to build them, right? It's actually not an easy feat, even if you end up using some of the powerful libraries out there, D3, CherryPy, what have you. So what we decided to do, we would give you a tool, MongoDB Charts, that allows you to easily, intuitively build data visualization on top of MongoDB data, get them in the interactive mode, fantastic. But the most important part, the most important capability of MongoDB Charts is that it actually respects the document model. It is document aware. It doesn't flatten your documents into the tables and pivot tables, and so you can do some analytics and run some visualizations. It natively understands them and allows you to handle your hierarchies, arrays, and so on. So using the very simple drag and drop interface, you can build powerful visualizations. You can actually grab those charts and assemble them into dashboards. You can have those dashboards be automatically refreshed. You can share them with other users. But the most powerful thing about MongoDB Charts is how much it actually simplifies the job of a developer by allowing you to take those charts that are built through the tool and embed them as live charts into your applications. So doing something like this in your web apps or mobile apps, this is truly sensational. Just think about it for a moment. If you had to do it on your own today, how much effort it would take, right? And then the other thing that is super important about the embedding capabilities of MongoDB Charts is that you can actually personalize them and context it to the user who has logged in, right? So not only we would do the enforcement and make sure that authentication and the access control is all respected, so you can only see the charts that you're entitled to see, but we can actually personalize what you see based on your identity. Isn't that great? Don't you think this is really, really, really important? Yeah. How do you do that in a matter of minutes? Can it be done in a matter of minutes? Well, oh, you don't think so? I'll challenge you. In fact, I think this can be done, and I'm going to give you a demo. And in order to do this demo, I'm going to invite on stage me to give you the demo of MongoDB Charts. This is how excited I am about the embedding capabilities of MongoDB Charts. So let's rock and roll, shall we? All right. Suppose we're running a company that builds activity bands, right? And let's say I have built some powerful dashboards for fitness tracking. You can see all kinds of different visualizations, right? This is all great. I'm actually going to delete this one. And we can also support geo visualizations, heat maps, and you can interact with them and everything. So this is all cool. So what I'm going to do now, I'm going to build a new chart that allows me to track the number of steps per day, and I'm going to embed it in an app. Okay? Let's see how quickly I can do that. First, let's add a new chart. Add a chart. Use the data source that I already onboarded. Look how easily and quickly it recognizes the underlying schema. Now, I think I'm going to choose a column chart type, which is very appropriate for the type of visualization that I'm about to build. And I'm going to grab the activity date and move it on the x-axis. And I'm going to grab the total number of steps and move it on the y-axis. And off you go. In a matter of a few seconds before I even manage to finish my sentence, you've got a chart here. Now, this is actually grouped by month. So I'm going to bin it by the date of the month, which will give me a better histogram, by the date, every day of the month. And this looks way better, right? Now, one thing you'll probably notice if you're paying careful attention is that this number of steps a day seems a bit excessive, right? I mean, I'm not a Superman to do this. But what's happening here essentially is that this chart is showing you the total number of steps of all the users that I'm tracking in my database, right? So, well, not to worry. We can handle this with some filtering capabilities that we have built into MongoDB Charts. So I can go and filter by user ID, and I can deselect all users and just pick one user. And this makes much more sense, right? So this is my data and my chart. And this would have been perfectly fine if all I wanted to do was to build a chart, put it in some dashboard, and keep going back to just by myself, so in this kind of a self-service manner. Now, if I'm a developer and I want to give this, functionality in the app that my users have, and I might have thousands or millions of users, creating thousands of millions of filters is non-feasible. That's crazy, right? So we're actually going to do that. We're going to delete this filter, reset it, and I'm going to save this chart as a generic chart, and let's just call it the number of steps per day. So what I'm going to show next is how I can take this chart, I'm going to put it back on the dashboard, and not only embed it in my app, but also make sure that I can personalize it to the context of the user who logs in. Okay? So let's first find our chart. Here it is. I'm going to go and click Embed Chart, and you can see here that we give you two options, right? Two options of how you can do your embedding. First, you can embed in an authenticated mode, which basically gives you an iframe, you copy-paste, put inside your web page, off you go. That's it. Just HTML, very straightforward. Of course, it's insecure. And again, the fitness data is probably something that you want to handle with a little more care. So we're going to put some authentication on it, and we call it verified signature. So when I enable the authenticated access with the verified signature, you can see it actually generates a little bit more of the data. And I'm actually going to go and copy this this ID, this chart ID, because I'll need to use it later when I'm going to tie this chart in my function that is responsible for generating chart in my app. So I'm going to close this for now. Let's go back now to the app that I'm empowering here, that I'm enabling. I have a very basic web app that I want to, once I log in, to display the chart of that activity that I just built, and I want that chart to be contexted to me. So there's a little bit of work that I need to do, but before I do that, I want to point you out to a repo of charts embedding examples that actually gives you walkthroughs, what you need to do in all these different languages and platforms. Very, very straightforward. Just follow those examples and you'll be in very good shape. So I'm going to use MongoDB Stitch actually here and basically follow these steps. And if I go to MongoDB Stitch, I have a basic web app, and I'm using Stitch static hosting, right? And then inside the index.html, I have some JavaScript that will end up calling a function, a Stitch function called render chart. This is the one. Just to save us some time, I put some of this boilerplate code that I took from the guidance page. Okay, it just timed me out. Let me get back into my function. So now I'm inside Stitch. Where's my functions? Right here. So you can see here, this is all pretty straightforward. And you see some details of what you define, bunch of different keys. You can set some properties around the expiration and so on. So now what I'm going to do, I'm going to quickly supply my chart ID that I want to be embedded in my app. And this is the chart that I just built. Remember, I just copied that chart ID. And then and this would be fine, but it will give me that generic chart. I don't want the generic. I want the filtered one, right? So I'm going to define a filter on this that could be any MQL query. In this case, I'm actually going to supply the filter to be used in the context from Stitch, user ID, and that's pretty much it, okay? So this is going to be used when the chart is rendered. I'm going to save it. Now I have to deploy it. I'm going to push it to deploy, and of course you can use our UI, or you can use any of your CI/CD tools in the backend to get this all picked up and deployed in real time. So now I'm going to go here. I'm going to reload my app to make sure that I get the latest, okay? And I'm going to log in. And as I'm logging in, I'm going to actually use this Stitch infrastructure for authentication and the access rule enforcement, but I have a couple of different ways how I can do this. But I'm going to use the name and password. So as I log in, what you see, it actually had recognized me. And now if I click on my latest activity, you actually see this chart that I just built. And it is not a generic one. It's actually contexted to my specific journey, my specific activity. Isn't that great? Yeah, don't be shy with the plus. And if you still don't believe me that this is a live chart, let me just do this. I don't know. Let's just quickly, who wants to volunteer and give me a different color instead of green? What's your favorite color? Red. Well, I don't know. There's no red by default. I'm going to use pink. And I'm going to save this. And as I go back to my app and I refresh this, you can see the chart loaded. It's a live chart. It's not a static image. It's absolutely live. And if it was the interactive one like a GeoChart, you can actually play with it and interact. So there you have it. In a few minutes, literally, that was less than 7 minutes, I was able to build a chart, embed it in my app, and make sure that it is personalized to whatever filter I choose to, okay? We believe charts is the best way to visualize document data today, okay? It's available both, it's actually GA, so it's a fully supported product, and it's available both as a service in Atlas, so you don't even have to install anything, or you can actually run it on-prem. We make it available as a Docker image. Let's move on. Let's talk about real-time now. Real-time is something that every app wants to be, and last year we added database triggers. Database to Stitch. And now in the Stitch, you can write this serverless function response to any of the changes in the database. Maybe I shouldn't touch my microphone. Now, what this year we're doing, we actually gone further. The Stitch database triggers were so popular that we're actually gradiating them at the level of the database, at the level of Atlas itself. So now, you can actually use the power of the triggers directly through the Atlas UI, okay? Now, think about the different use cases when this could be useful, when this is really valuable. Let's say you are doing an insertion of some document in your collection and you want to send an SMS message, right, informing somebody about this. Another thing could be, let's say you are updating something in your collection, and then as a result of it, you also want to update a materialized view. Thank you. And I'm doing this magic. Look at this. No hands. Can the world hear me? I know we're streaming. Yes. Wonderful. Thank you. So another scenario that comes to mind is that, say, you are removing a user, and then based on that change in the database, you also want other systems, right, to purge that user from their systems as well. And you may want to do that by putting some kind of a message, right, or event on a stream, a service bus, and I don't know, perhaps a Kafka, right? So speaking of Kafka, what we have released is the preview of MongoDB Kafka Connector. And it actually is built on top of the community-developed connector, but we took it further, so now you have the support for both source and sync. And we also made sure that it is certified by Confluent and available on the Confluent Hub. So definitely, please check it out and take advantage of it. Now, when we talk about MongoDB, when we talk about making it easy for you, for developers, work with data everywhere, of course, the story would not be complete if I don't talk about mobile, would it be? Yeah. So we want to make sure that no matter where you are, including mobile, you can enjoy the same kind of experience. Now, one thing that you probably know, a few months ago, we made an acquisition of Realm. Realm is by far the most popular mobile database today, right? In fact, and if you have a phone with you, it's very likely that you have Realm running on it already behind the scenes. So why is MongoDB and Realm such a good fit together? Well, the developers are very productive. The same principle as we wanted to make developers productive on MongoDB, the same principles Realm was built on. Plus, in case of Realm that deals with all the objects, you actually want, developers want to have some kind of a document style model, okay? They don't want to deal with ORMs. So this is actually the summary of why mobile developers love Realm. Everything is built as objects. You think in objects. Everything is very, very natural. It's all integrated with different languages and platforms. And when I talk about that it feels like objects, you have the support of all the things you expect, right? When you're doing the object-oriented programming. You have observability, you have concurrency, you have transaction safety. All of that is there. And the important thing that Realm gives you, it actually removes a ton and ton and ton of boilerplate code. It removes all that stuff that you needed to deal with before, all the ORMs, all the leaky abstractions. None of that is present anymore. Now, while Realm is great, we're actually going to make it even better. So we're going to improve the Realm core based on what people have been asking. So Realm, again, is staying as Realm. We're not breaking it. Don't worry about it. All the Realm fans, but we're going to extend it by adding support for unstructured data. So you're going to see sets and dictionaries and any mixins. All of that is going to be added along the way of supporting things like cascading deletes and supporting inheritance, making Realm even more object-oriented-like, and giving you the powerful analytic and transformational queries. Plus, we're going to expand Realm to support additional platforms. Now, if you think that was great, we're actually taking it even further. Our vision for this future of MongoDB Realm platform is very, very exciting. So, as I said, we're keeping Realm as Realm, but we're actually going to build a universal sync solution. A universal sync solution sync to MongoDB. And if you think about sync, sync supports a whole number of different use cases. You want to use sync when you need to do the backup, right? Your phone to the database. And again, you want the data, you're already dealing with the object data, documents on your phone. You don't want to transform it into rows and tables, right? You want to make sure that you can save it natively. You also want to support cross-device synchronization, right? So if you think about using your phone in an occasionally connected scenario and you want to get sync working and also with all the underlying conflict resolution, this is all going to be baked in. And then, of course, if you think about building a mobile app, you don't want to be spending a lot more time building the web app in a different way. You want to be able to reuse the backend across mobile and web. We're also going to, so here's actually the vision, how it all comes together. From Realm, we're going to get the mobile component, so we're going to have the Realm database and the sync. So here's the mobile piece. From the core database, we're going to get the stitch authentication and declarative rules, which are very, very powerful. So we're replacing the access model. And we're also going to contribute the stitch functions and the ability to do code deploy from GitHub or GitLab, something that will just do it very, very easily in the continuous delivery model. So this is going to be the core backend. But now we cannot forget about the web. So for the web, we're also going to include the ability to do query anywhere, something that we released with Stitch before, which basically allows you to run your MongoDB query from the browser without building a custom REST-based API. And the static hosting that I already showed you, where you can just host your apps directly in MongoDB. So all of this together will become MongoDB Realm. And we're super excited of what we're building there. This will be the best way to build data-intensive apps anywhere. If you want to learn more, by the way, about Realm, please attend the talk later today. All right. Now, the last thing that I want to talk about today is a problem that many of us have today. We have accumulated tons of data, enormous amounts of data, and very likely most of the data sits together somewhere where in S3 buckets, right? Because S3 is so cheap. Now, what do you do with that data? How do you query it? How do you query it in real time? Well, I'm super excited to share with you that we actually built a separate product and a service to address that very problem of querying your S3 data. It's called Atlas Data Lake. And it allows you to do the in-place query against your S3. It's all kind of pay-per usage, and it also supports the formats that you care about, anything from JSON all the way to Parquet. Also supported in compression to make sure it's very efficient. And the nice thing is that, again, when you're querying it, you still preserve the proximity to those S3 buckets, and you don't need to incur any of the additional costs of egress. So you can use the standard MQL language. You can use all of our APIs, and nicely, you can also use all of our tools, the shell, the drivers, the compass, even charts to go against Atlas Data Lake. For you to truly appreciate the power of Atlas Data Lake, you guys need to see a demo. Don't you want to see a demo? Yeah. Come on up, Scott. Please give them the demo of Atlas Data Lake.
Thanks, Grigori. Good morning. So let's go ahead and start out in S3 over here. So we've got a list of buckets. I'm going to use the fitness data bucket. This is the same data that Grigori used in the charts demo. So if we drill down into it, you can see we've got a lot of different file types. So we've got some just straight JSON. We've got some CSVs, some TSVs. We've got compressed JSON down there. Looks like some developers have been playing with Avro and put a file in as well. We've also got some Parquet, compressed files. So really, we've got a hodgepodge, kind of a mess of files out here. So if we take a look, I mean, there's nothing magic going on with the files. So if we look at one of the JSON files, just standard JSON. Okay, so what do we want to do with this? So what I'd like to be able to do is use a rich query language that can handle rich data formats and query the data right in place on S3. So last year in June at MongoDB World, or this year in June in MongoDB World, we actually announced MongoDB Atlas Data Lake, which allows you to do just that. So if we jump over into Atlas, you'll notice we've got a data lake section here on the other side. So we're going to go through and configure a new data lake. So first we need to give it a name, and we'll just call this Houston Demo. And it needs the name of our bucket. So let me flip over here real quick. We'll copy the name of the fitness data bucket. And paste it in. There we go. Okay, so now we need to find a way to give Atlas access to our S3 bucket. And we do that by creating a role and then applying a policy to it. So we'll just call this HOU demo role. Put my initials in so I can go and find it and delete it later. Okay, so we're going to run a couple of S3 commands. So first I need to create a file named dltrust. Oops. And we'll go over here, bring the file up in my editor. We've already supplied all the content, so you just need to simply copy it, paste it into your editor, save your file, and issue this command. This will create a role. Awesome. So now we need to create one more file that passes the parameters to create a policy, so we give only read-only access to Atlas. Oops. Let me copy this again. There we go. We'll copy in the content, paste this in and save it. And one last command. And we're done. Okay, so Now we're actually in the process of creating the data lake, so it needs the resource that we just created. So this is an ARN, Amazon resource name, kind of a unique name for that role. We'll give this over to Atlas, validate and launch. And there we go. So we've got a data lake just created, and now we need to connect. So this is no different than a typical MongoDB database, so same type of connection strings, and we'll just use the shell. So let me copy our connection string here. You guys really don't want to see my password, do you? All right, there we go. So let's take a look at the databases. And we don't have anything out there initially. So there's one more step, a little bit more of config information that we need to tell about our S3 buckets, and that's how to map those over to databases. So let me load a config file that I wrote a bit earlier. There we go. And here's the configuration we're going to pass in. So there's two sections to it. The first one defines the S3 buckets. So where's my data stored? And this one you can see we're accessing the demo fitness data. We're doing a simple subdirectory within it. It's in the US East 2 region. Then I need to tell it how to map those files back to my databases. So you could do it in a very specific format, so saying I want this database and this collection to map to this file, or you can do it kind of in an automagical way, which is what we're doing here. And this is just telling you to create a fitness database, and for every file out there, we want you to create a collection and use the root of the file name, everything to the left of the underscore. So let's go through and apply this. It would help if I could type. I don't have the luxury of typo forgiveness like Karen had in her demo. All right, there we go. Now, it takes show DBs usually a couple of minutes or so to populate, but if I restart my shell, I can get there a little bit quicker, so we'll just do that. There we go. And now we have a fitness database. And we've got a collection for every file that's out there. So let's just take a quick look at some of the data. We'll look at hourly steps. Okay, and we can see we're getting data out of it. So what I've done is placed a couple of functions here to save you guys suffering through my typos again. So if we look at a simple aggregation, we've got one called steps. So we're going to go through that same hourly steps collection. We're going to group by user, and we're going to sum up all of the steps that user has taken. So we'll just execute this function. Okay, there we go. And I've got one that's a little bit more complex. And this one will go through the daily activity collection, pulling in the day with the most steps for each user. It's going to take them all, sort them, and then give me the top 5, so I'll get the people that have walked the most per day. And let's go through and execute this guy. Okay, and there we go. So you can see these guys have taken a lot more steps in a day than I probably have taken this entire month, but it's definitely taken a lot fewer steps for us to create an Atlas data lake. So with that, I hope you guys enjoy the rest of the conference. Back to you.
Thank you, Scott. Wasn't that awesome? Yeah, very, very powerful. So just to remind you, a very, very quick recap. On the core database, we're making lots of improvements and enhancements, and we are bringing to you distributed transactions that now work both in replica sets and sharded clusters. We are supporting retrievable reads and writes. We're also giving you more expressive updates in the query language that will make you write less code. We're supporting on-demand materialized views and wildcard indices. All phenomenal enhancements to the core database. On the operational front, we talked about things such as Ops Manager renewed headless backup. We talked about the Kubernetes operator that is now GA. We talked about Atlas autoscaling and ISO compliance, as well as my favorite feature, field-level encryption. We also talk about how we're extending MongoDB as a data platform. And in there, we covered Atlas full-text search. We covered the MongoDB charts to build your visualizations, as well as database triggers and Kafka Connector to support your event-driven architectures, MongoDB Realm as the future vision for Mongo Mobile, and Atlas Data Lake. Whew, that's a lot of stuff. We're working tirelessly to make sure that MongoDB Data Platform is the best, is the easiest way for you to work with data for all the developers, no matter what your use case, no matter what platform you're on. On that note, before I wrap, I want to thank all of you. As well, I want to thank my co-presenters, Karen and Scott, and the entire production crew that actually makes this event possible and brings it to you here in Houston, and then streaming it live everywhere around the world. Thank you so much. Enjoy the rest of the day.
Please enjoy a snack break at the back of this room or downstairs. Sessions will begin at 10:30. Again, snacks at the back of this room or downstairs.